So hi children, in this video we are continuing the problems from 11 onwards. Okay, so what is that number? 483. So here what we have to find out? Total sum of the divisors of 483. Okay, so first we have to write that prime factorization of 483. No, so 483 is not divisible by 2, so we have to go for that 3. So 8 plus 4 12, 12 plus 3 15, 15 is a multiple of 3, no? So that given number is divisible by 3. So 3 16s 48 and 3 1s 3. Is it clear? Now here 161 is there. So 161 is a prime number or not? 161 is a prime number or not here? So see here 161 is a prime number or not? Okay, 161 is not a prime number. 167 is a multiple of 7. Okay, let us see that. 7 2s 14 and here the leftover 21 is there. So 7 3s 21. Okay, that's why here 23 is a prime number. Yes, obviously 23 is a prime number. So leave that one. So 23 ones 23. Clear? Now we have to write that prime factorization for 483. Okay, so what is that prime factorization here? That is 3 power 1 into 7 power 1 into 23 power 1. So what we have to find? Sum of the divisors. So sigma of 483 we have to find out. Okay, so what is that formula here? 3 power 1 plus 1 minus 1 whole by 3 minus 1 into here 7 power 1 plus 1 minus 1 by 7 minus 1 and here 23 power 1 plus 1 minus 1 by 23 minus 1. Okay, now simplify this. 3 square minus 1 and here 3 minus 1 is 2. Next 7 square minus 1, 7 minus 1 is 6. Okay, and here 23 square minus 1 by 22. So here 3 square is equals to 9 minus 1 whole by 2. Okay, into 7 square is a 49 minus 1 by 6. Next 23 square is nothing but a 529 minus 1 by 22. Okay, that continuation see here. Okay, 9 minus 1 is 8 by 2 into 49 minus 1 is 48 by 6 into another one 528 by 22. Okay, now cancellation see here. So 2 4s. Okay, next 6 8s 48. Next here cancellations. Cancellation by 2 is possible, no? 2 11s and here 2 2s 4, 12 2 6 12 and 2 4s 8. Is it clear? Now 11 1s 11, 11 2s 22, 11 4s 44, which means 11 24s cancellation possible. So here 4 into 8 into 24. Okay, now do that multiplication. 4 8s 32 into 24. So do that calculation here. 24 into 2 is equals to 48. 24 into 3 is equals to 72. 72 plus 4 is equals to 76. So what is that resultant here? 768. So what is the sum of that all the factors of a given number? That is 768. So which option is correct? That is option C is correct. Okay, children, here if you don't know the table of 24, okay, then directly you can multiply that 4 into 2, 4 into 3, 2 into 2, 2 into 3. Okay, so directly I written here 24 into 32. Okay, or else you can see like this also. 4 2s are 8, 4 3s 12, 2 2s 4, 2 3s 6. So here 8, 6 and 7. So like this also we will get the same result. Okay, this is the shortcut. If you know the table of 24, that is easy. Okay, if you don't know the table of 24, then you have to go for this one. Okay, so this is that solution for that question number 11. Next question number 12. Okay, let us see this problem. Find the sum of divisors 1980. So before going to write that, here we need to find that prime factorization of 1980, right? So here, okay, first we need to take that prime factorization of 1980. So here 2 9s 18 and here again 2 9s 18 and 0. Now here 990, here we can take that 11 multiple, no? So 11 nines 99 and here 0. So 11 90s 990. So 90 is divisible by 2 now. So 245 is 90. Okay. Now here 5 nines 45. So 3 3s 9. So again 3 1s 3. So what is the prime factorization of 1980 here? 1980 prime factorization, we can write the standard form as 2 repeated here 2 times. So we can write this one as 2 square. Next 2 after 3. So here 3 repeated 2 times, no? So that is 3 square. And the next one is here 2 are completed, 3 also completed. Next one is 5. 5 only once there. So 5 power 1. So after 5, 7 not there. So next we have to go for that 11. So that is 11 power 1. Okay, so this is the prime factorization for 1980. So now what we have to find? Sum of the divisors. So sum of the divisors formula is sigma of 1980 we have to find out, no? Okay, so here what is that formula? 2 power p plus 1. So what is the value of p here? That is 2 plus 1 minus 1 whole by 2 minus 1 into 3 power 2 plus 1 minus 1 whole by 3 minus 1, okay, into 5 power 1 plus 1 minus 1 by 5 minus 1 into 11 power 1 plus 1 minus 1 by 11 minus 1. Clear? So here which is equals to 2 power 2 plus 1 is equals to 2 cube minus 1 and here 2 minus 1 is equals to 1. So into here 3 power 2 plus 1 is equals to 3 cube minus 1 whole by 2 into 5 power 1 plus 1 which is equals to 5 square minus 1 by 4 into 11 power 1 plus 1 is equals to 11 square minus 1 by 10. Clear? So 2 cube value is equals to 8. 8 minus 1 by 1 is no need to write, right? So here 8 minus 1 into 3 cube value is 27. So 27 minus 1 whole by 2. Okay. Into 5 square is 25 minus 1 whole by 4. Into 11 square is 121 minus 1 by 10. Okay. After that simplification, 8 minus 1 is 7. Next here 27 minus 1 is 26 whole by 2. Into 25 minus 1 is 24 by 4. Into 121 minus 1 means 120 by 10. Clear? So 0 and 0 gets cancelled. Here 4 6 24 and 2 cancels 26 by 13 times and here 7. Okay, now here the multiplication 7 into 13 into 6 into 12. Okay, so what is that product here? 7 into 13, 7 13s 91. So 91 into 6, so how much you will get here? 6 1 6 6 9s 54. Okay, that is a 546. Next 546 into 12. So 12 into 6 is equals to 72. So carry over 7 here. 12 4s 48. 48 plus 7 is equals to 55. Okay. 12 5s 60. 60 plus 5 is equals to 65. Okay. So what is that resultant here? 6552. So what is that option? 6552. Okay, so first for that every number, first we have to write that prime factorization. After that we have to see that question. In that question what they are asking. Okay, number of divisors or sum of divisors or product of divisors, which question they are asking. Okay, first we have to see that. So after that we have to go apply that formula and next substitution, next simplification. Okay, so this is about the 12th question. Now see that next one. 13th question, find the product of the divisors of 24. Okay, so product of the divisors formula, what is that? Here product of the divisors, that is represented by pi of n. So product of the divisors of n, product of the divisors of n. So what is that formula means? N power half into d of n. So what is the meaning of this one? Here product of the divisors is equals to n for here given number. So we have to write that given number power half into number of divisors of the given number. Half into number of divisors of the given number. Okay, just see that here which number they are asking, 24. So product of the divisors means, just see that for example 10 is there. So what are the divisors here? 1, 2, 5, 10. So what is the product of these divisors means, we have to take the product of these all factors, right? So 1 into 2 is equals to 2, 2 5 is 10. So 10 into 10 is equals to 100. Okay, this is the product of factors of 10. Okay, so what is the product of the factors of 24? Okay, here also like this we can take, but here if that is the greatest number, then how you will take? At these cases you have to apply this formula. Just apply this formula here. So n is equals to 10. So 10 power half into d of n. How many factors are there here? 4 factors are there. So 2 2's 4, which is equals to 10 square. So 10 square is nothing but 100. 10 square is nothing but 100. So by using directly multiplication also we are getting the same result only now here. Okay, that's why apply that formula here. So what is that symbol we have to represent for that product of divisors means pi of n. Okay, now we need to find for that pi of 24. The given number is 24 now here. Okay, here no need to write that any factorization. To find that number of divisors we have to write that factors. Okay, number of factors. So here n is equals to 24 whole power 1 by 2 into, here what is that prime factorization of 24? 2 12's 24, 2 6 12, and here 2 3 6, 3 1's 3. Clear? So here 2 cube and 3. D of n is equals to 2 cube into 3. So we can write this one as 3 plus 1 into 1 plus 1. So here 3 plus 1 is 4, 4 into 2. So here we will get it as d of n is equals to 8. D of n is equals to 8. So here this is 8. So 2 4's 8. So what is that here? 24 power 4. Okay, so which option is correct here? Option A is correct, that is 24 power 4. Okay. So let us see that next one. Find the product of divisors 512. So again here, before going to find that product, we have to find that number of divisors. So D of 512 we have to find out. So 512 we can write it as 2 power 8. Okay, 2 power 9. 2 power 9 is equals to 512. No? So D of 512 is equals to 9 plus 1, which is equals to 10 factors are there. How many factors are there here? 10 factors are there. Okay. Now here product of the divisors of 512. Product of the divisors of 512 we have to find out. So here what is that formula again here? 512 power half into d of n. D of n value is equals to 10 no here. So 2 1's, 2 5's. So which is equals to 512 power 5. What is that result? 512 power 5. So which option is correct? Option A is correct. 512 power 5. Okay. So next one. Find the product of divisors of 1244. So before going to that, just n is equals to 1244, no? Just like that previous question only. So here prime factorization first we need to find out 1244. So divide with 2, 2 6 12, 2 2's 4, 2 2's 4. Clear? Next 2 3 6 and double 1. Okay. So here 311. What about that 311? That is a prime factor. 311 is a prime factor. That's why we can write this one as 2 square into 311 power 1. Okay, that is the prime factorization for that 1244. Now, D of 1244 means a number of divisors. So here 2 plus 1 into 1 plus 1. So which is equals to 3 into 2 is equals to 6. Okay. In totally we have that 6 factors now here. Now product of the divisors of 1244. So which is equals to 1244 whole power half into number of divisors. That is 6 only no. So 2 1's, 2 3's. So which is equals to 1244 whole cube. 1244 whole cube. Okay, so which option is correct? Option B is correct. Is it clear? So for the product of factors, the product of the factors of any given number, first we have to find that number of divisors. We need to find that number of divisors of a given number. After that we have to find that product of the divisors. Okay, now the next question, assertion. Number of odd divisors of 32 is 1. What is that? Number of odd divisors of 32 is 1. What is the reason? Number of odd divisors of the number in the form 2 power k is 1. In the form 2 power k is 1. Let us see that. For example, 2 power 1 is there. So here value is 2 only, no? What they are asking here? Number of odd divisors. So factors of 1. Sorry, factors of 2 are 1 and 2 only, no? Next, 2 square value is equals to 4. So factors of 4, 1, 2, 4. Okay, next 2 cube. 2 cube is equals to 8. Factors of 8, 1, 2, 4, 8. Okay, next 2 power 4, 16. 1, 2, 4, 8, 16. Is there any other factor? Not there. Okay, so when you observe this one here, 2 power 1, here how many odd factors are there? Only one odd factor. 2 square, only one odd factor. 2 cube, one odd factor. 2 power 4, only one odd factor. So if that number is in the form of 2 power n, then here that number is having how many odd factors? Only one. Why? Because for each and every number, 1 is the common factor for all numbers, no? 1 is the common factor for all numbers. That's why here 1 is that odd factor. Remaining all factors, 2 power any number, always you will get that even numbers only, no? That's what we discussed at the time of number of odd factors, number of even factors. Okay, so the same concept here we have to use. So what is that given assertion? Assertion means given statement. What is that statement? Once see here, number of odd divisors of 32. Number of odd divisors of 32. 32 is that 2 power 5 value is equals to 32. 2 power 5 value is equals to 32. Now here 32, its prime factorization is in the form of 2 power n only, no? So if that number is in the form of 2 power n, how many odd factors are there? Only one odd factor is there. So assertion is correct and reason is also correct. Reason which one they given, that is correct explanation for that assertion. So which is correct option? Both A and R are correct and R is the correct explanation of A. So option A is correct. Come to the remaining options. Both A and R are correct, but R is not correct explanation. R is not a correct explanation. Here reasoning is that correct explanation of that assertion, no? So both also correct only, and R is that, here individually those two are correct only. Okay, here the second which reason they given, that is related to first assertion or not? That is related to that only. Okay, so that's why R is the correct explanation of A. Okay, so this is wrong. And come to the next one. A is correct, R is wrong. What I am saying, those two also right only, no? Okay, that's why here option A is correct. Let us see that the next one. The highest multiple of 97. The highest multiple of 97 less than 1282. So first we need to divide the 1282 with 97. Okay, so 97 ones 97. So its difference how much? 8 minus 7 is 1, 12 minus 9 is 3. Okay, now here drop down the 2. So the nearest number is 97 into 3. Just check this one. 3 7s 21, 3 9s 27 plus 2, 29. Okay, let us take that 97 into 4. 4 7s 28, 4 9s 36 plus 2 is equals to 38. Okay, that is greater than this number, no? That's why lesser this number we have to take. That's why 97 3s 291. 291. What is the difference? 1. And here 31 minus 29 is equals to 2. So the difference is 21. Okay. So here 1282 minus 21. 1, 6, 2, 1. Okay, so what is that greatest multiple, highest multiple of 97, which is less than 1282? So what is that greatest multiple here? 1261. So 1261 is that greatest multiple of 97. Okay, so which option is correct here? Option D is correct. Okay, so let us see that the next one. Number of prime factors of 54. Number of prime factors of 54. Here they are not asking prime factorization. Number of prime factors. Okay, number of prime factors they are asking. So we have to write that prime factors. So first this one we can write it as 227s. Okay, next we can write that this one as 3 nines, and here we can write this one as 3 threes. This is a factor tree, no? So by using that 2 3 6, that is one of the factor, and 3 3s 9, that is also one of the factor. 3 3s 9, 9 3s 27. So by using this method also we can write that factors of the given number. Okay, if you are confusing with this method, then you can go for that any other method, that is multiplication or division method. Okay, so multiplication method also see once. 54, how we can write? 1 into 54, next 2 into 27, next 3 into 18. Okay, next it is not a multiple of 4, no? Okay, next 5 also not possible, next 6 nines 54, next 7 not a multiple, 8 is also not a multiple. Next, so next one is 9 only, no? So in repetition we will get. So here 1 2 3 6 9 18 27 54. So these all are the factors of 54, no? Now what they are asking? Number of prime factors they are asking. So prime numbers are 2 3. Is there any other prime number? Not there, only 2 prime factors are there. So option B is correct. Okay, so here first you have to write that the factors of the given number, after you have to say that prime factors. Okay, next 19th one, number of odd divisors. Number of odd divisors of 32. Number of odd divisors of 32. Prime factorization of 32 is 2 power 5 only, no? So just before question only we discussed that. Okay, what is that? If the given number is in the form of 2 power n, then the number of odd factors is 1 only, no? Okay, so which option is correct? That is option 1. Okay, so next one, number of divisors of 6. So 6 we can express it as 2 power 1 into 3 power 1. Correct? Okay, 2 power 1 into 3 power 1. So here number of divisors. So D of 6 is equals to 1 plus 1 into 1 plus 1. So which is equals to 2 into 2 is equals to 4. In totally we have that 4 divisors. In totally we have that 4 divisors. So 6 is having how many divisors? 4. What are those? 1, 2, 3, 6. Okay, these are the divisors of 6. So let us see that next one. Number of even divisors of 18. Number of even divisors of 18. So first we need to find that D of n. So D of n means how to write that to 18. 2 9s 18. So 2 power 1 into 3 square. Shall we write like that? 2 power 1 into 3 square. So which is equals to 1 plus 1 into 2 plus 1. So 2 into 2 plus 1 is equals to 3. 2 3 6. Okay, so how many divisors are there for that 18? That is totally 6 divisors are there. Number of odd divisors. Here we have to see that number of odd divisors. How many odd divisors are there? Just we have to check that only odd number powers only, no? Odd primes powers. So that is 2 plus 1, which is equals to 3 odd divisors are there. How many odd divisors are there? 3 odd divisors are there. So now number of even divisors. So what is the formula to find that number of even divisors? That is total number of divisors minus number of odd divisors. Then you will get that number of even divisors. Okay, if you have doubt, already previous this type of questions we discussed, no, that's why I told you this one like this. Okay, I didn't write any formula here. Why? Because related to this question, similar questions already we discussed. Okay, if anybody missed those videos, once go to that videos and check that. Okay, so here option 3. So which option is correct? Option C is correct. Okay, now question number 22. What is that? Here, sum of the divisors of a given number. Sum of the divisors of a given number. Okay, sigma of n is equals to sum of the divisors is equals to 3. When it is possible, every number is having that most sum, right? But here when it is possible, n should be greater than 1. We know that n should be greater than 1. So let n is equals to 2. Let us take that n is equals to 2. Here d of n is equals to how much here? 1. D of n is equals to 2 only, no? And in the same way here we can write this one as 2 power 1 also. Yes or no? 2 power 1 is equals to again 2 only, no? That's why. So here sum of n is equals to, we can write this one as sum of n is equals to 2 power 1 plus 1 minus 1 whole by 2 minus 1. So which is equals to 2 power 1 plus 1 means 2 square minus 1 by 1. So 2 square is 4 minus 1. So which is equals to 3. So it is satisfying or not? Satisfying, no? That's why here n is equals to 2 is correct option. If you take that n is equals to 3, then 1 plus 3 you will get there. So 1 plus 3 is equals to 4, you will get its sum. But here they are asking its sum is equals to 3. Okay, so when it is possible means when that n is equals to 2, then only that is possible. So here option B is correct. Okay. Next, 23rd one. Prime factorization, prime factors or prime factorization of 2520. 2520. So here this is divided by 5. 5 5 is 25, 0, 5 4 is 20. Clear? Next, divides with 2. 2 25 is 50, 2 2 is 4. Okay. Next, 2 1s 2, 2 2 is 4, 2 6 12. Next, 2 6 12, next 2 3 6. Okay. Next, 3 2 6, 3 1s 3. 3 7s 21. Now here 7 1s 7. Okay. So let us see here. How many times 2 repeated here? That is 2 cube into 3 repeated how many times? 2 times. So 3 square. Next 5 here only one time there. And here 7 is also there at only one time. So which option is correct here? 2 cube 3 square 5 into 7. So option 1 is correct. Which option is correct? Option 1. Is it clear? Let us see the next one. Sum of the factors of 28. Sum of the factors of 28. So first 28 can be expressed as prime factorization, no? So 2 into 14. 14 again we can express it as 2 into 7. So we can write this one as 2 square into 7. Okay. Now what they are asking? Sum of the factors they are asking. So sum of the factors of 28 is equals to 2 power 2 plus 1 minus 1 whole by 2 minus 1 into, this is 7 power 1, no? So 7 power 1 plus 1 minus 1 by 7 minus 1. So which is equals to 2 cube minus 1 whole by 1 into 7 square minus 1 by 7 minus 1 is equals to 6. So here 2 cube minus 1 which is equals to 7. 8 minus 1 7 into 7 square 49. 49 minus 1 is 48 by 6. Okay. 6 1s and 6 8s 48. So 7 8s 56. Okay. What is that result? 7 8s 56. So what is the sum of that? All the factors of 28 means 56. Okay. Double of that given number. Is it clear? So next one. If d of n represents a number of divisors of n, then d of 18. Just see this question, very very important. d of 18. This value we need to find out. Okay. So before going to this one, we have to find that number of divisors of 18. So divisors of 18 first we need to find out. So how to write this one? 2 9s only, no 18. So 2 power 1 into 3 square we can write this. 2 power 1 into 3 square. So here d of n is equals to 1 plus 1 into 2 plus 1. So here 2 into 2 plus 1 is equals to 3. So 2 3 is 6. Okay. So number of factors is equals to 6 factors we have here. Now again we need to find out that this value we got it as 6 only, no. Now here this value we need to find out. Okay, d of 6. D of 6 means this one we can write it as 2 into 3. So 2 power 1 into 3 power 1, which is equals to 1 plus 1 into 1 plus 1. Okay, so 1 plus 1 into 2, sorry, 1 plus 1 is equals to 2 and 1 plus 1 is equals to 2. So 2 into 2 is equals to 4. Okay, so how many divisors are there for 6? That is 4 factors are there. 1, 2, 3, 6. 4 factors are there. So what is that option? Option A is correct one here. Okay, once again see that question. Here they are asking number of divisors of 18. Okay, number of divisors of 18. First we need to find that number of divisors of 18. Okay. To that 18, how many divisors are there? 6 divisors are there. Now, number of divisors of 6 we need to find out. So, here we got finally that is 4 divisors are there. Okay, so which option is correct? That is option A is correct. Okay, so let us say that the last question. Product of the divisors of 512. Product of the divisors of 512. So, 512 we can express it as 2 power 9 only, no? 512 we can express it as 2 power 9. Now here number of divisors. So d of 512 is equals to 9 plus 1. So how many divisors are there in all? 10 divisors only, no? Now here what we have to find out? Product of the divisors. So pi of 512. Product of the divisors they are asking. So product of the divisors formula, what is that? 512 power half into 10, half into number of divisors only, no? So here 2 5s. So here we are getting that 512 power 5, but here option not there. Then what we have to do? Just observe that in that given question which options given? All are in the powers of 2 only, no? So that's why here this 512 convert this one into the power 2 power 9. 2 power 9 whole power 5. Now 2 power 9 into 5. So here 2 power 45. So what is that resultant here? 2 power 45. So option A is correct one. Okay. So don't be confused that here 512 is there, but here in options all are there in the powers of 2. Okay, already I told you that actually here 512 that prime factorization is 2 power 9 only, no? So directly to the 2 power 9 they applied. So if you want to apply here then also correct, or else if you convert like this that is also correct only. Okay, so up to here your worksheet also completed. So fundamental number theory total concept completed. So if you have any doubt then comment in that comment section. I will clarify your doubt in that next session. Okay, thank you all.